Okay, so this is a question on the homework, and I don't think the circuit was ever made it to the handout. So I'm gonna find initial conditions for it. Here there may be 2 videos for this, but for t less than 0, we want no capacitors, no inductors, but we do want to have the voltage across the capacitor and the current through the inductor. And the idea is that we find scalars at 0 minus. And once we go to t larger than 0, you know, these two values will move over. They magically transcend time, only, you know, at 0. So looking at this circuit here, what happens is, I'm sorry for the bad drawing, but this is a switch, and it's in the beginning turned down, so the tail set tells me what's t less than 0, and at the end, when we do t larger than 0, we're going to make it hook up, connect to the top part of the circuit, which means these 5 volts here are not connected to anything, so they are in air. And I am going to not draw these 2 because the capacitor is the minus and the plus. Really, it's across the 3K. And the inductor, this switch is closed, it's also measuring current here on this side of the circuit. And these 2 circuits then are connected through this node here that I'm going to maybe paint in yellow, but there is no other node for t less than 0 connecting these 2 circuits. It's almost like 2 independent circuits. So this one yellow node is the only, you know, connection there. But let's see how this shows up. So I'm not going to draw the capacitor, but I do need the minus and the plus. And this is the 3K, this is 2K, 10 volts, 5K. So really what I'm asking you, what is this voltage here? If this is 10 volts. And the second is the inductor is now in parallel with the 2K, which means that 2K is not making any difference. In the 2 milli U of minus t means that this is active for t less than 0, and then it's going to turn off for t larger than 0. But for now, this here is the new circuit. So once you drew this, if you're doing this on an exam or on your homework assignment, if you drew the circuit for t less than 0, you can go back to, look, I now have a circuit that has no capacitors, no inductors, and I need to find that current and that voltage. Often it is simple. I recognize people in class trying to put capacitors and inductors, like, oh, how do you solve a circuit with capacitors and inductors? We don't know how to do it yet. So here is a 1 loop that I could do KVL on. So if you have, I'm actually going to just draw this in pink. If you see this, it's going through the 3K, 2K, and 5K. And I could do KVL and say, look, it's 10 volts minus whatever is here, whatever is here, whatever is here. But if you add up these 3, 2, and 5K, you see that it's 10K. I know maybe you will have questions, wait a minute, why is this voltage division? But I'll tell you this here, the capacitor really behaves like a voltmeter, so it's not breaking the, you know, serial connection here. So these are all in series. And secondly, maybe you're going to say no, but there's current here. But what happens here is that the IL will be minus 2 milliamps. So because IL is shorting out the 2K, really this current does this. Look, the 2 milliamps that goes down here goes up here. So this individual loop stays with like the 2 milliamps, and there is no other current from here going into or coming out of this side of the circuit. And therefore, these two are really 2 independent loops. And therefore, it's 3 plus 2 plus 5, and I know that this VC is 3 volts. So if you have to write on the exam, you can just say by inspection. So there is no Ohm's law, there is no KCL, no KVL. This is as simple as it gets. So these two numbers are what we're asked to find for t less than 0. Now we're going to do t larger than 0 in the next video. I hope this was simple enough, but I'll leave it here. For t larger than 0, we're looking for dVc of 0 plus dt, and for dIL 0 plus dt. And we're going to draw the inductor and the capacitor this time. So here I want to say one more thing. The capacitor looks like a voltmeter. The inductor looks like an ammeter, so it's just measuring. But as soon as we use those, VC is 3 and IL is minus 2 milli, these look like they behave like power supplies. For the second part of this of initial conditions, so if you're having issues still finding dV dt and di dt, know that these two numbers here, you can think of them as like, now I have a 3 volt power supply. What is the current through it? Once you find the current, you're going to say, if I find that current through that 3 volt power supply, I'm going to use this formula, the relationship between current and voltage, which is I equals C dV dt. And once I find the voltage across the inductor, I'm going to use L di dt to find only at 0 plus those two derivatives. Oh, so these are again two scalars that we want to find for t larger than 0, but we'll talk about that in the next video.